So today we're continuing our learning of categorical data. So you're needing to go back over this and make sure you have a full grasp on it before we move forward. So with categorical data, we're looking at bar graphs, dot plots, circle graphs. We're analyzing the data that they've given us to understand what it means or how to use that information to determine something else. So what is categorical data? Categorical data places someone or something, which you should make sure you have in your notes, into several groups or categories. So for example, favorite color, job titles, names of students, and so forth. Quantitative data, and think quantitative, quantity type, measures numerical values such as age, height, number of siblings, and so on. So what is a dot plot? A dot plot is a data display in which each data item is shown as a dot above a number line. So if you take a look at this dot plot, it has airline training program tests. So new trainees, and this is their time in seconds. So each dot, and it shows us here, represents one person. So for example, here at 71, it shows us that 3 people completed their training program test in 71 seconds. There are going to be times where each dot does not represent one person. Say, for example, it represents 5 people. So then we would say that 15 people, if we're reading this graph, completed the training in 71 seconds. So make sure that you're paying attention to that as well. All right, so let's practice with dot plots. This one says the students in a class were surveyed to find out how many people live in their household. Household members might include parents, step-parents, guardians, and siblings, as well as extended family such as grandparents. The results of the survey is shown in the dot plot below. So how many students were surveyed? Well, in this case, I don't see a key like we saw in the last one, so we're going to go ahead and assume each dot represents one person. So we're going to count our dots: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there were 25 students that were surveyed. So then it says, what percent of the class has a household of 3 or fewer people? So does it include 3? Yes, because it says 3 or fewer. So I'm going to look at everything at 3 or to the left of 3 and count those. So I have 1, 2, 3, 4, 5, 6, 7. So there's 7 people that have 3 or fewer. Now when we find a percent, we have to remember back to earlier in the year that we did part over whole equals percent over 100. So there's several different ways we can solve this. We can use the proportion like we're used to. So 7 out of 25 equals x over 100. We do our cross product. So 25x equals 700. We'd work to get our x by itself. We divide by 25, divide by 25. And I know that 25 goes into 700. Let's see, 25 goes into 100 4 times. So 700 is 7 times that. So 4 times 7 is 28. So it would be 28. Another way to solve it is to divide this original fraction or ratio. So I could do 7 divided by 25. And will we get the same answer? Yes, we should. So 25 does not go into 7, but it goes into 70 twice. 70 minus 50 is 20. Add a 0, bring it down. 25 goes into 100, like we said, 4 times. Twice that is 8. So 200, and that's 0. So it's 0.28 or 28%. So either way we get the same answer, but we know that 28% of the class has a household with 3 or fewer people. Okay, so now let's take a break real quick and think about ratios. So we talked about ratios as a fraction before, right? Like a rational number. So we could write a ratio as 2 over 3, but we could also write a ratio as like 5 to 2, or say 3 to 1. These are all ratios, just written in different ways. But something to think about is we will be using 2 different types of ratios today. So one is part to whole, and that's like we did on the last problem. We said how many out of the total were had a household with 3 or less. So it would be part over whole. And that is, for example, like how many girls are in our class out of the total number of students in our class. Another type of ratio we use is part to part. So an example of that, and we would do one part, like part A over part B. And that would be, for example, how many girls there are as a ratio to boys. So these are 2 types of ratios we will look at today. Okay, so Colleen is training over the summer for a triathlon. The amount of time she spends training daily is displayed on the dot plot. So how many days did she spend training? Let's take a look and see. So what do we have to do to figure it out? We just count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 dots, and it tells us that each dot is represented by the number of hours she worked out one day. So we're going to go on to the second. It says, what is the ratio of days that Colleen spent training 5 or more hours to the number of days she spent less than 5 hours? So I'm going to write a ratio of 5 or more. So does that include 5? Yes. So greater than or equal to 5 hours to less than 5 hours. So not equal to 5, but less than 5. So I'm going to look up at my graph, and I'm going to draw a line between 4 and 5. So my first ratio, it says greater than or equal to 5 hours. So I have 1, 2, 3, 4, 5, 6, 7 to the right of my line. So I'm going to put 7 here to less than 5. So 1, 2, 3, 4, 5, 6, 7, 8. Because less than 5, not equal to 5. So 7 to 8. So that is my ratio for the number of days she spent 5 or more to less than 5. That is a part-to-part ratio. Okay, so now it says approximately what percent of days did Colleen spend more than 3 hours? So let's take a look. It says more than 3 hours. So is it equal to 3? No. So greater than 3. So I have 3 is right here. We want more than 3. So anything to the right of that line. So we know there's 7 to the right of 4 plus 2. So we're at 9. So there's 9 days that she spent more than 3 hours training. Now to do a percent, we need to do part over whole. So this is a part to whole ratio. So 9 over the total is 15, sorry. And then we need to turn it into a percent. So you guys stop and do that now. Okay, so you had two ways of solving it. You could either divide it or you could simplify. So I'm going to simplify and say I know that these are both divisible by 3. So I'm going to divide them by 3 and I get 3 over 5. Well, if it's over 5, I know that it goes up in intervals of 20 because it's 20, 40, 60, 80, 100. 100 divided by 5 is 20. So 3 times 20 is 60. 20, 40, 60. So 60% of the days she spent more than 30 hours training. Okay, so now let's move on. So what type of data would best be represented in a dot plot? So we already took a look at several options. We did some with numbers of households, some with hours. I've seen some with heights. So for me, I think that frequency is the best type of way that we would present information in a dot plot. So like the number of occurrences or the number of times that something happens. That's a great example of how to do it. So I'm going to go ahead and put frequency. Okay, so now let's take a look at bar graphs. So what is a bar graph? A bar graph displays data with vertical or horizontal bars. So bar graphs are a good way to display data that can be organized into categories. So we'll see some in categories. You'll also sometimes see them based on months and things like that. It's a quick, easy way to look at data. So let's look at this practice one. Use the graph to answer each question. So it has fat content of an Italian sandwich. The sandwich has dressing, cheese, ham, salami, and bread. So what ingredient contains the most fat? So fat is at the bottom, so I'm going to look at the graph that goes out the furthest. And I see that the one with the most is dressing at 10 grams of fat. Who would have thought? How many more grams of fat are in salami than in ham? So with this one, I'm looking at ham, which is right here, and I'm looking at salami, which is right here. And so we're looking at this distance between the two. So we have salami is at 8, and ham is at 5. So how many more means we're going to subtract. So 8 minus 5 is 3. So 3 more grams of fat. So how many total grams of fat are in the sandwich? So we're going to just add them up. So we have, let's see, 10. We have 7, 5, 8, and 2. So 10 there, I have 10 here, and then 12 here. So 12 plus 10 plus 10, so we're at 32. So 32 grams of fat. All right, so let's move on to the next one. So what percent of total fat in the sandwich are from salami? So we're looking at salami. It's at 8. So this is a part to whole. So 8 over 32. What percent is that?